All right, here we go. So this is going to be first a review of the chain rule. So I'm just going to give it an example. Let's suppose that f of x equals the sine of, let's say, 3x cubed. I want to find the derivative f of x. All right, and to do that, we're going to take the derivative of sine, which is cosine. And then we're going to take the derivative of the inside piece, which is going to end up being 18x squared. Now, what we are working with today is a little review of what we did on class, the last period, and it's going to be called U Substitution. And if you recall that we can take the antiderivative or integrate our f prime of x dx. And that's going to end up with f of x plus c. And so in this situation, I can, my original f of x up here, let's add, I don't know, a 10. We can still get the same derivative. So down here, if I want to integrate, I'm going to put this 18x squared here. If I want to integrate this particular function, since what we did up above we know what the antiderivative should be. Okay, so when we do that, we should get, or we will get, sine of 6x cubed plus some c that we don't know. All right. All right, so let's suppose we don't know what the original function is, and we just have the integration that we have to work with. So let's integrate this particular function. And what you want to look for is, since this is what I call U sub, which is really just integration by U substitution, we're going to need to pick our particular U, and that's typically going to be the most complicated piece in that original integration. And so let me go over here, and I'm going to let U be x cubed plus 1. And if I'm going to make that a U, I'm going to have to find something that is equal to my du. Because in order to integrate a function in terms of u, I have to have a variable of integration, which is this little du. That's what it tells us. So let's come over here and take the derivative of u. And so what's the derivative of x cubed plus 1? We get 3x squared dx. And that 3x squared dx is actually in my original problem. So this u is to the third power, and the 3x squared dx over here is my du. All right, and so my rewritten expression now is the integration of just u cubed du. And we know how to do that. Integration of u cubed, we get 1/4 u to the 4th plus c. But again, if my original function started in terms of x, I have to replace that u back in. So I get 1/4 x cubed plus 1 to the 4th power plus c. Now, what's awesome about integration is we can check our work. And so, well, that's not check. Yep. Looks like a C. There we go. We can check our work by actually taking, so we're going to check by taking the derivative. So let's do that. So that gives me 1/4 power rule to the third power. Derivative of c is 0. And then the derivative of the inside piece by chain rule is 3x squared. Simplifying, I get 3x squared, x cubed plus 1 to the third power. And lo and behold, shebang, up here, that's exactly what we started with. Alrighty, I'm just going to do one more example. And so we're going to integrate 4x squared minus 3 to the 3/2, and I have x dx. So what we're essentially doing with U substitution, or integration by U substitution, is we're doing the reverse chain rule. So again, I'm going to let my more complicated piece of my integration, I'm going to let that be U. I'm going to find du, which gives me 8x dx. Now, if I go back to my original integration, I don't have an 8. So I'm going to divide both sides by 8 or multiply by 1/8. That eliminates the 8 on the right side, replaces the 8 or 1/8 on the left side. So now I have my x dx. X dx is right here. And for x dx, I'm going to replace it with 1/8 du. And my 4x squared minus 3, I'm going to put a u in there. Okay, so my expression becomes u to the 3/2. The x dx, I'm going to put the constant out in front, and the dx right here. And then we know we add 1 when we're integrating. And so I get u to the, that's going to be another 2/2. So we get 5/2. We get 2/5 right here, times the 1/8, plus c. Simplifying this, I get 1/20. Our u, we have to substitute back in. And we're now to the 5/2 power plus c. And there's our answer. All right, and lastly, here we have x times the square root of 2x plus 1 dx. We have an x on the outside of the square root and a 2x minus 1 on the inside of the square root. So this is a little bit trickier. Again, we're going to let u be the more complicated piece. Du then becomes 2 dx. Again, I don't have a 2, so I'm going to move that 2 to the other side and make it 1/2 du. Now, we got a little problem here. We have something to replace 2x minus 1 by, but we don't know anything about this x right here. So what we're going to do is we're going to come over to our original u sub, and I'm going to solve that for x. So I get u plus 1 over 2. That's equal my x. Now I have an x. So let's come back. So we're going to come back over here, and I'm going to put this x right here, and then I'm going to put the u right there. So my integration becomes u to the 1/2, and the x is that mess over there, u plus 1 all over 2. My dx is 1/2 du. So I have to make all those replacements. I have to make a replacement for x, which is over here. All right. Then I need to make a replacement for u, well, 2x minus 1, which is right here, and also dx, which is 1/2 du. All those little pieces have to go together already. So let's pull out all the constants, 1/4, because that's 1/2 times that 1/2. And then we have u plus 1 times u to the 1/2. We can distribute that and get u to the 3/2 plus u to the 1/2. Okay, we know to add 1 to each of these. So I'm going to get 1/4 u to the 5/2. We've got a 2/5 right here, plus u to the 3/2. We have a 2/3 right here. Oops, plus c. All right. And that little bit of room here on this page, we're going to come up. I got to put our original u back in. So I'm still going to leave this 1/4 outside. 2/5 original u, 2x minus 1 to the 5/2, plus 2/3, 2x minus 1 to the 3/2, with a little plus c.